Greetings everyone. Hope this video finds you all in good spirits. Today's lesson, we are readdressing the concept of tessellations. I asked you guys to watch the video that I put up on tessellations, just kind of giving us a good brief introduction into the concept. In this video, I just wanted to go over some of those main concepts and as well have a little fun exercise or way of understanding this concept. This concept to me is a very important concept in math because it deals with the idea of patterns, and as I've said to you guys many times, patterns is a reoccurring theme throughout mathematics and throughout almost everything we do if we pay close enough attention. All right, so this is a fun exercise, a fun way to see how patterns play a role in our everyday lives as well in mathematics. All right, so the first question we have was, what is a tessellation, or what are the two requirements for a shape to tessellate? You could pause the video and fill in your answers. Again, I asked you guys to please take notes as you're watching the videos, so that way you're able to refer to your notes and go back and the information doesn't get wasted. All right, so I'm gonna just text in my answers here. So we know that tessellations, right, are patterns that are formed by two or more polygons that cover an area or a plane without any gaps or spaces in between the shapes. Okay. Period. All right. Hopefully you guys got that right. You wrote that down in your notes or kind of have it already locked into your memory. All right, and then what is the other part or requirement in order for a shape to tessellate? In order for a shape to tessellate, we know that the vertices or interior angles of the polygons must equal 360 degrees, period. If they do not equal 360 degrees, then they are what we would call an irregular polygon, meaning that their sides are not all equal or angles are not congruent, and therefore will not necessarily create a tessellation, at least without any gaps or spaces, or you needing to include another shape to complete the space or area. All right, so the next question was, where can tessellations be found? In the video, they gave us some examples. I had also asked you guys to do some research as well to see, come up with your own examples, find some natural examples within your home. But we know that tessellations can be found in nature, right? They can be found on certain animals. For example, turtle shells. You can find them on fish scales. You can find them in snake skin. In certain fruits, you could find them in pineapples and in certain citrus fruit, raspberries, plant cells, sunflowers, etc. Right? These are all naturally occurring patterns in nature, which I think are beautiful on a mathematical as well as artistic level. It could also be found, obviously, in the art, right? In many paintings, ancient paintings, modern paintings that are famous use this style or this pattern in their art. It's also seen in our clothing, in fashion, in our designs. You can find it in our chain link fences. You can find it in tiles on the floor, in brick walls. You can find it on graph paper, sidewalks, etc. So there are many ways that you can identify this concept of patterns completing a space or an area um, through either reflection, right, transformation. Um, there are different ways in which we are able to see how patterns repeat themselves, right? Okay. So here I have an exercise for us to do. What I would want us to do is basically we would take an area on a piece of paper and we would use a ruler to create our plane, okay? Then what we're gonna do is, if you notice that I have these numbers, I have 1 centimeter, 1 centimeter, 1.5 centimeters, then 1 centimeter, 1 centimeter. On top, I have 2 centimeters, 2 centimeters, 2 centimeters. And on the bottom, you would do the same. You would mark your 2 centimeters, 2 centimeters, and your 2 centimeters. Right? On this side, we would have the same 1 centimeter, 1 centimeter, 1.5 centimeters, back to 1 centimeter, 1 centimeter, 1.5. Okay? Then we would take our ruler and connect our grid with our pencil. This is going to be a fun exercise that after we get our individual practice, try to get this ruler, we will be able to put something together and put on our bulletin board. Okay, so we would take our lines and connect them. Here we go. And obviously, oh wait, there we go. Okay. That didn't work. And this is good that you guys can see I'm not as straight. It just takes time and patience. This doesn't have to be perfect for me because I've already done it. I'm just giving you guys an idea of what we'll be doing, and you can get started on your own. Okay, now it does need to be precise, right? Because that's how we're going to get our angles to add up. If we remember, we said one of the requirements is they have to, our internal angles have to equal 360 degrees in order for our pattern to tessellate, right? In order for it to repeat itself and cover our space. So here we have, this is basically what I started on. It's the same thing. I had my 2 centimeters, 2 centimeters, 2 centimeters, 1 centimeter, 1 centimeter, and 1.5. If you notice that it's a pattern, right? Up top and on the bottom, it's a distance, an equal distance of 2 centimeters. And the ratio on the side, we have 1 centimeter, 1 centimeter, and then 1.5 centimeters, right? And that's a repeating pattern, which allows us to create a repeating pattern. Once we have that, we continue to complete our lines. Just so you guys get an idea. And the good thing about the video is you guys can always pause and go back and take your time with it. Okay, then we start to, oh, I need that ruler again. We take our one centimeter and we connect it to our there we go, right? And then same here. This is just going to be easier for me to do it this way. All right. Then we're going to repeat that pattern. Oops. I'm still learning how to use this thing. And then, yeah, let's start with this side. Get that again. Oh, you know what? I'm missing a line here. There you go. All right. And then okay. keep connecting these dots all the way through, and eventually this is what you'll have on your frame, all these squares. And then you start to just fill them in, and you use 3 different shades of a color, right? So I used blue. I used these 3 shades of blue. This was my side, this blue was my top, and then this darker blue was my front face. Okay, so let's see, I'll use, yeah, that was my top, so I'll finish to show you guys. That's what's going on. It's like, what is that doing? There we go. So again, you would just take your time and make it nice. But I just want you guys to get an idea of what it will look like. And I also want us to just make a note that the reason why we can see this pattern developing, again, we can test it and we can see that we have a cube, right, which represents a 3-dimensional shape of squares, made up of squares, right? And so we know squares have 90-degree angles, and if we could see, we see 90, 90, 90, 90, which will meet our requirement of 360 degrees, right? 360 degrees of the internal angles, right? Where our vertices meet. Wherever they meet, they should always add up to, whether it's on the top, 90, 90, 90, 90, on the side, 90, 90, 90, 90, and we'll always add up to 360, so we know that this shape is going to tessellate, right? That's the cool part. So again, just color in a few more pieces so you guys get the idea. See, I'm gonna do my top. That is my top. I'll make this my top again. So we can do this, you can do this obviously on a device, but you could also just use a ruler, pencil, some colored pencils, and do this also with material. Okay, so now the front is my darker blue. Sorry. And the fun thing about this exercise is as you go through it, the dimensions open up as you start to color and put it together. You start to see it come together, which is pretty fun. face, and then my side is light blue, and so this would be my side. Again, it would be much neater if I'm taking my time. I just wanted to give you guys an idea of how it comes together. Oops, sorry. And so, again, this one is not as neat because I'm kind of just rushing through it. See if I can clean it up a little. Oops. But you guys get the idea, right? And you just would continue to color and fill in. This part right here, I would make this my top. So that would be this color. Right? This is my face. And by the time I take my time with it, it will look nice and neat and cleaned up. This again, I'm just showing you guys an idea of what it looks like. Okay? Make it smaller so you don't see all the little missing gaps. But that is what the idea is. We can use different shapes. The last question again is what 3 shapes could we say naturally tessellate? What 3 shapes? Well, we can use an equilateral triangle. As we can see, we know squares as well as a regular hexagon, right? These are shapes that will naturally create a pattern without any any area or space in between the shapes. Okay, so again, the first thing you do is you take a regular plane, 2-dimensional area, and then you space it out in this type of a ratio: 1 centimeter, 1 centimeter to 1.5, and 2 centimeters to 2 centimeters. You can increase the numbers, but you want it to be the same type of proportion, right? So that's the idea, and hopefully you guys will have fun with this and we can make a fun bulletin board. All right, thanks, and see you guys soon.